What's up, YouTubers? So it's a beautiful Saturday, and I figured why not spend the day showing you guys how to weld uphill, so vertical up with flux core wire, because I'm sure you may have off, or you may be working on some project in the garage, or now that summer's kind of getting closer, you might have a project you want to work on, and being able to weld vertical up is very handy, because if you can't do it, that kind of limits you. You know, you can't reposition everything you might weld on into a flat or horizontal position. So the sooner you learn how to weld vertical up, the better off you are. So that's what we're going to be talking about. Let's get into it. So for today, we're going to be welding on 1/8 inch, 3.2 millimeter roughly, just straight mild steel. Now I cut and cleaned up all of these. You can see how clean this is. This is what you want to practice on. You know, if your stuff is scaly and rusty, how do you know that it isn't a material issue if you get porosity and stuff? So start out with clean material. Now I got a big chunk of steel from an old welding project when I was in school, and I got a C-clamp here. And I tacked 3 of these in a row for vertical up, and it's pretty much straight up and down. Hopefully the footage turns out all right. I'm probably actually, you know, that's why I got this plate. I'm going to tip it a little bit so that hopefully it comes out a little bit better on the camera. Now, before we actually get to welding, I'm going to do a short book learning section right now, and it's simple. So what you have to remember is flux core wire is one of the few processes that's actually really easy to weld uphill. And I say that because, well, I know you're going to struggle for a little bit, and you're probably not going to be able to get the results as fast as I can, but that's all right. It will come with time. So the reason it's so easy to weld uphill is that the molten puddle tends to freeze very fast. If you've ever tried hardwire short circuit MIG and weld uphill, you're probably going to notice that welding uphill with it, if you don't do a manipulation on 1/8 inch, you're going to watch your bead sink and sort of drip in a weird way. It's going to be very difficult, and even when you reduce your settings very low, you may still get that. And that's simply because the molten puddle with MIG takes a little bit longer to solidify, and the faster it freezes, the easier it is to run uphill. So flux core wire, self-shield, is very easy to run uphill. Far easier than stick because it maintains essentially an arc gap of sorts. So anyways, with that said, what I find is a great starting point is that if you can run a bead on plate and it's slightly cold, so a little bit roped up, that's about what you want to have for settings for running uphill. And let me show you what I mean. So I have my welder fired up. I'm running 16 volts and 190 inches per minute on the wire feed speed. Now that wire feed speed and the voltage is a little bit lower, well, I would say not a significant, but a fair pinch below what is recommended for 1/8 inch material. We're going to make a short weld, look at it, and based on the appearance of that, determine if it's suitable for welding uphill or not. So let's do it. So let's take a look at what we got here. If you look at that, it's still pretty flat. It's not roped up. We start having a little bit of a crease of penetration out the back. The heat affected zone is pretty big. That looks all right. I would like to see it a little bit colder than that, so a little bit more crowned up, but I think that's something we can work with. If this bead is very flat, and I'll show you that now. So I went up to 17.2 for voltage, 210 for wire speed. Let's look at that weld. So right away, you see how orange that is because it's so hot and it's staying orange? Once that cools off a little bit and I clean it, we're going to see the bead is wider and it's flatter. That's a good indication that we're running, you know, plenty of heat. Now, in the flat position, that would probably be more than acceptable. Like if we were doing a lap or a fillet weld, those values may work. But when we're doing uphill, we need to lower the amount of heat and lower our wire feed slightly. That way we don't carry so much heat with it that our molten puddle starts drooping down. Let me clean this off now. So right away, and I didn't clean it that well, but you can see it's without question wider. It's rougher looking. The back side we see from this angle, I'll angle it. You can see how there's a really big crease there, much bigger than the first pass. Great indication, plenty of heat there. Like I said, that would be more or less acceptable for doing lap welds or fillet welds, but not in the uphill position. So you want your welds to look like this or slightly colder, and that will be the starting point to work with for doing uphill. So I'm going to get everything repositioned and get set up for arc footage, and we're going to watch this first pass vertical up. We're going to look at it and talk about it. Before we get going here, I'm going to mention a couple quick things. Your gun angle, you want to be straight in or a slight push angle when welding uphill. You don't want to do a drag angle. So in a lot of ways, it's similar to welding with stick uphill. Nothing new there. Now, as far as your angle to the plates, you can weld straight in, and on thin material, that would be your best bet. However, on thicker material, if you weld straight in, you're going to end up, like on a lap weld, you're going to end up welding the back plate and nothing on the front. So in that case, thicker plate, you want to have an angle towards the root, and that's what I generally do. So now let's get back to the actual arc footage and stop staring at this awesome scenery. I'll repeat this without comments next. So pretty much I'm oscillating up and down. Due to my settings being in the ballpark, I don't have any molten metal running or anything, so that's looking pretty good. Just watch it in the next video, see what I'm doing. So let's talk about what we see here. Now, I was able to successfully weld vertical up without having it drip, but there's room for improvement. So we've successfully made it. The bead looks a little bit tall, so it's a little bit far off the plate. There's evidence a little bit of pin dot porosity, and if you look, this appears to be not crowned up or like caulk, but it looks like it could flow out a little bit more. So we have a couple choices that we could make right now. If we add up all of the details here like it's a game of Clue, all of the clues, we can deduce, okay, a little bit of porosity, very minor, a little bit cold. Well, we can either lower our wire feed speed a pinch to match our voltage a little bit, so our heat to metal ratio will remove some of the metal, or we can bump up the heat. Based on what I'm seeing here, I'm gonna take a guess and we're gonna drop the wire feed from 190 that it was at, and we're gonna go to about 175, and we'll see what happens with that. And I'm gonna weld right here after this all cools down. So we're gonna knock a little bit of wire feed off. So this is the same footage, just with commentary. Now I'm just oscillating up, down a little bit, holding up, down, and that's allowing me to progress forward at a reasonably steady rate. I had a little bit of a rough start, but for the most part this is welding okay with slightly different settings. So let's take a look at what we got. Now, this weld from about this point up is exactly what we want to be aiming for. Now down here, my travel speed was a little bit inconsistent, but this is what we're looking for. If you look, it's not humped up at all like this weld is, so that's looking really good. If my wire was aimed at the center here, you can see our melt over the edge was very minimal. Now this looks worse than it is because that's where I stopped, but our melt over, if you look down here, is about right, just a millimeter over the edge. When you look at this, it's actually melted far more over, and that's due to the increased heat, due to the increased wire feed speed. But yeah, this point up is exactly what we want to be aiming for. Not humped up, the toes aren't really cold. And you have to put this in perspective. I know, this looks a little bit inconsistent here, but we're looking at a pretty small weld. I mean, this is a 332 tungsten, and this weld's only maybe twice as wide as it. So, this is a very small weld. It's not like we're welding on 1/4 inch steel here. The other thing worth noting, and you probably saw it in the arc footage, I have a tendency to slightly oscillate up and then back, up and back. That seems to help because when you move forward and then stop and then move back and forward, the puddle below where you move from will solidify, and then it gives you something to build on. You can actually run straight in and just drag it right uphill. And by drag, I mean I'm coming in with a pretty much straight in angle. But you can just go smooth and straight, but I find that it's a little bit easier with a little bit of a stitch movement, kind of like this. And you saw it in the arc footage. So this is looking decent, pretty good. I think I can do a little bit better than this. So I dropped the wire feed a pinch, and we're at 175, same 16 volts. I'm gonna bump the voltage up to 16.3, and we're just gonna run a pass on this top part. I'll flip the plates over, and we'll look if it makes any difference. So this is the same video. I had a little bit rough of a start. I think my stick out was just a little bit too long, and once I got it a little bit tighter, it cleaned up. And I think that's all it was. But yeah, this one welded pretty good overall, no real complaints. Let's just take a look at it in a second. So I flipped this plate upside down just to make it a little easier to see, but I welded this from the bottom up. Now when we compare this weld to these two, you can see just 0.3 volts created a weld that is flatter. I mean, without a doubt, look at the shadow line here. The shadow is telling you that this is slightly humped up. Same thing here. And here we have almost no shadow line, especially from about the halfway point up. Is looking real good, real consistent. This is a little bit inconsistent, but again, we're talking a very small weld here. I mean, we're, maybe 2.5, 3 32nd electrodes wide, so not very wide at all. Again, first weld, cold, so too much wire, not enough voltage. Our metal to heat ratio, metal to voltage ratio was off. Here, a little bit better. Still not off, still off, still not on. Here, kept the same wire feed, and it's looking a lot better. This is more or less what you want to see. Now I'm going to tip this just to show you. A lot of it's simply the lighting, and you can play with the lighting and it looks different, but out of all three of these so far, this is what you definitely want to be aiming for. Now I have a little bit of inconsistencies on the toe line here, which is very common welding vertical up. This, I mean, from a strength perspective for 1/8 inch is definitely strong enough, more than strong enough actually, because there will be penetration in the root of this, plus a slight, cap that's a little bit above the base material. But what I think I want to try and do, I'm going to bump up the voltage to 16.4, maybe 16.5. We'll say 16.5. And I'm going to try and run as consistent as I can start to finish on this one. So I'll flip the plates over and we'll try it again just to compare and contrast. So this is the same footage. It's really difficult to get a clear arc shot of flux core wire because there's so much smoke coming out of it, it just obscures a puddle. But the puddle is about the size of where you see that bright light there. That is the puddle. If your puddle's longer than that, you're running too hot or going too slow. All right, so a little bit increase in voltage and trying to run consistent. My start was really good. Everything till about this point was really good. I think at this point it just kind of jerked it a little bit. It stepped out enough and then it essentially underfilled this area. This I thought was porosity, but I think it's just a little bit of undercut right there. It could be porosity. Not too surprising. Again, and then it settled in, looks pretty good. So this is, I mean, pretty much perfect up until where I kind of moved a little bit. And you probably saw maybe something changed in the arc footage at this point. This has a little bit of undercut on the side or underfill. I think it's just from moving too fast. That could also be, you know, again, travel speed increase and then it doesn't fill. So at this point, considering how much of this weld is exactly like what I would want, where it's not all crowned up and it doesn't really have any defects, I know that my settings, you know, plus or minus 0.2 volts, plus or minus, you know, 5-10 inches per minute of wire feed, I'm dialed in. And then the final change is just going to be controlling my welds with how fast and consistent my movement speed is. But we're dialed in, and you can see how much more crowned up this first weld, the second, you know, much flatter. It still has a little bit of a round profile. Same here. This point is further away, and I'll show you. You know, you can see based on the lighting, this does have, and yep, you can see it's under fill here, where the travel speed increased, therefore it didn't fill that. You don't see any here, and you can see that undercut there just went a little bit too fast. Same thing up here. It's funny how the light will play tricks and you can see stuff like that, but you can definitely see it still has a crown to it, which is good. It's not perfectly flat, but that's looking real good. So I'm happy with those results. I now know that for practice purposes, where I'm at, I should really leave the settings and just focus on, you know, my travel speed and just being more consistent, which is the struggle of everyone. I mean, settings are settings. The consistency of you welding is the far harder part, honestly. Well, let's conclude this episode. So in conclusion, I think it's safe to say that the smallest tweaks can make a huge difference. Now, on face value, these really aren't too much different. I mean, if you look here, you can definitely see the difference though. How humped up, that's really excessive reinforcement. Down here again, you know, excessive reinforcement, it's humped up. And then you start looking at these guys, that's about perfect. And then this one, about perfect. Now, this was done with 035 flux core. If I had to make a choice on 1/8 inch, which is what this is, I would much rather run 030 flux core, especially indoors where porosity is less of a issue due to you know, lack of air movement. And 030 is going to just give you a better tie-in, I guess. It's going to me, it's going to run a little easier on 1/8 inch. Now above 1/8 inch, you're definitely better off with 035 like I'm running now. And to be honest with you guys, I generally use 030 flux core for everything. And if I need 035 to weld thicker stuff, I'll just switch to stick welding. You know, that's why I had to go out and buy an 035 wire just to do some videos with. But yeah, it really proves the point that your metal to heat ratio or your heat to metal ratio is very important. And you can tell just by looking at any weld you have, if it's humped up like this, adding more voltage, aka more heat, will flatten it out. If it's too flat or concave, or just you're burning through material, drop the voltage a little bit. And you also have to remember that your wire feed speed it dictates how much actual amperage that you're running, but your wire feed dictates the weld size that you're depositing. So when you look at most welders on the inside of their chart, it'll say, well, 1/4 inch steel, use this wire feed. Well, that's assuming you want to make a pass that is fairly decent in size for, say, 1/4 inch. Well, this is 1/8 inch material. We don't need high wire feed because we want to deposit a smaller weld. There's no reason, like how humped up this is, that was too much wire. We don't need a weld that big. So by cutting the wire down to deposit an appropriate amount of metal, that allowed us to get closer to where we should be. Now, like I said, there's definitely some more tweaks we can do, but at this point, I'm pretty confident saying it's just a matter of plus or minus like 0.1, 0.2 volts and 5/10 on a wire feed speed. And just really it comes down to a little bit of practice and a little bit of more consistent movement. You know, I haven't done vertical up on flux core with 035 in a very long time. Like I said, I always use 030, so I'm actually pretty happy with the results here. I'm thinking they're looking pretty good, all things considered. Now in a flat position, you know, if your welds look like halfway decent on uphill, then on flat your welds are going to look great because it's so much easier to weld on flat. But this video shows that uphill really isn't that hard and you don't need to be afraid of it. You just need to practice a little bit and use slightly lower values than you can get away with in a flat or horizontal. Now, with that said, I'm going to actually finish up the other side of this plate just to practice some more because, hey, I already welded it up. Why not, right? And that'll be the end of the video. I'm going to leave this in real time. This is 6-inch or 15.24 millimeter plate. So you can see how long it takes me. It takes me a long time. Travel speed is fairly slow. When you hear it kind of chugging a little bit rather than just a straight sizzle, that's because my wire stick out's getting a little bit long, and by pushing it in a little bit, it cleans it right up. It's kind of a dumb idea to just weld this back to back like I'm doing because it's going to weld like I'm running 20% more values, but I did it. It worked. Not proud of it. Kind of looks like a river of lava on that weld. Not bad. So you saw me weld these continuously start to finish uphill, same as I've been doing. This one ran really good That's looking about perfect. Doesn't really get much better than that. And then this guy, being that the plates are pretty preheated already, it looked like it was undercut. Maybe that's a little undercut, but definitely should have waited for it to cool down. You can see how just preheated plates can make a difference. You know, not having a camera in your face also helps, so made it a lot easier to weld that uphill. You can see the lower toe line is nice and clean and crisp. Could even use a little bit more voltage, but you know, the welds on vertical up will look slightly different than what you're gonna see on flat and horizontal, so I'm not too worried about anything I see there. That might be a little hint of porosity, but we won't worry about that little guy. Just a rough start on that. Anyways, thanks for sticking around. Hopefully you learned something. If you like tacos, give me a thumbs up. Till next time, guys. Thanks.